Hello everybody. Today I'm going to try and explain blockchain technology to you in the simplest terms possible. If you have any questions, throw them down in the comments below and I'll be sure to address them. This is a single system. This is the type of system that most people are used to working with. What's common to all computing devices is that they have a place where all the data is stored. On a single system, the owner has the power to create, store, edit, and delete the data as and when they please. The data on a single system is saved on the system itself. So for example, in this case, if you were to save a new Excel file or Word document on your computer, it would be saved right there locally. In this particular picture, the hard drive is where the data would be saved. So the tower on the right side of the computer screen. All right, that's fairly simple, right? Let's move on. This is a distributed system. It just means it's a bunch of computing devices which are connected within a network. The network can be set up in an enclosed space like within an office, or it could be accessed through the internet using your login credentials. Computing resources can be shared across a distributed system. For example, I could be using this computer and I could add some data into my system and it would update on all the computers in the system. Alternatively, another user could be using another computer in this diagram, and if they decide to delete some data, the data from their system would be deleted and then it would consecutively be deleted from all the other systems on the network as well. All right, moving forward. This is a blockchain system. It is essentially a distributed system with three distinct features. First, it has a much higher level of security than regular distributed systems. Blockchains use forms of cryptography to secure themselves. The security mechanisms include hashing and mining, topics which can get fairly complex. Second, data can only be added and updated on a blockchain system. The edit and delete functions are disabled. So for example, if I entered data indicating that I have $10 into the system today, the data will exist in the system forever. So any user can add data to the system, but no user can edit or delete the data from that system. Third, the data which is saved in these systems is structured in blocks. Think of it as tables of data stacked on top of each other to form a block. The blocks are then connected or chained together using a long string of text called hashes. That's where the name blockchain comes from. What this means is that there's no single point of failure. If one system or one computer gets corrupted or infected with a virus, the rest of the system still stays intact and unaffected. If this concept makes sense, let's move on to blockchain applications. When people say they're building a blockchain application, it basically means that it's an application that saves its data in a secure blockchain instead of locally on your device. Everything else remains the same except where the data is saved. The data in a blockchain is highly secure and tamper-proof because it can't be edited or deleted. Because this data is trusted, several programs and applications can be built using this data. This is why blockchain tech is considered such a big deal. I want to cover a few features of blockchain technology before we wrap up today. A blockchain is a network of connected devices, and not all blockchains are the same. In fact, there are several competing blockchains that exist simultaneously. Some are private and some are public. A company or private organization can set up their own internal blockchain which is not open for the public, while the most famous public blockchain that exists today is the one on which Bitcoin is built. I'm going to cover Bitcoin and other cryptocurrencies in depth in my next video, but for now I'm going to skip it. Each block of data in a blockchain has a few features that I want to expand upon. You can follow along by looking at the bottom half of your screen. Each block has a serial number and the count starts at 1. Every block also has a timestamp so that we know when all of the data within that block was entered. Each block also has a unique identifier called a hash. The hash for each block is copied forward to the next block, connecting the two blocks chronologically. Every block of data in a blockchain has a unique identifier, which includes components identifying the previous block before it. If any block of data is tampered with, its unique identifier, or hash, changes. This causes all of the unique identifiers going forward from that block to change as well. This usually doesn't happen because it requires too much computational power. In case it ever were to happen, though, the altered unique identifiers would alert the rest of the network, which would then exclude the compromised device from future transactions and keep the blockchain secure. Alright, I hope that was fairly easy to understand. If you have any remaining questions, drop them in the comments below. I'll be sure to answer them. Next week, we're going to build on this and talk more about Bitcoin and other cryptocurrencies. Thank you.